Stoichiometry measures the quantitative relationships and is used to determine the amount of products or reactants that are produced or needed in a given reaction, describing the quantitative relationships among the substances as they participate in chemical reactions. The first question: what is the volume in liter of a solution that contains 3.12 moles of NaCl if the concentration of this solution is 6.67 moles per liter? So the molarity M is equal to moles over liter. That means the moles over volume. So here we know the molarity 6.67 and is equals to 3.12 moles over x liter. So we can just do some algebra. X is equal to 0.468 liter. Next question: calculate the moles of sodium peroxide produced if 32.5 grams of sodium reacts with excess oxygen. Here is the chemical equation, and we know the mass of sodium is 32.5 grams, so we can get the moles of sodium, and it is equal to 32.5 grams times 1 mole over 22.99 grams, and it is equal to 1.414 moles. And look at the stoichiometry. So the ratio of the sodium and the Na2O2 is 2 to 1. So Na to Na2O2 is 2 to 1. So we use the stoichiometry to calculate. So the 1.414 mole, the moles of the sodium over x mole is the Na2O2, so it's equal to 2 to 1. So we can get the x is equal to 0.07 mole. But remember the suffix is very important. How many grams of CaCO3 need to produce 3 liters of carbon dioxide at standard temperature and pressure? STP is standard temperature and pressure, which means the reaction will happen at 273 K then 1 atm. And we know the volume of carbon dioxide is 3 liters, so we can get the moles of carbon dioxide. It's the 3 liters times 1 mole over 22.4 liter. It is equal to 0.134 moles. And the ratio of CaCO3 and the CO2 is 1 to 1, which means 1 CaCO3 can create 1 CO2. So the mole of CaCO3 is equal to 0.134 mole, the same as the carbon dioxide. then we can get the mass of CaCO3. So 0.134 mole times 100 grams per mole is equal to 13.4 grams. So here's the free response question from 2011 AB chemistry text. A student is assigned the task of determining the mass percentage of silver in alloy of copper and silver by dissolving a sample of the alloy in cis nitric acid and then precipitating the silver as AgCl. First, the student prepares 50 milliliters of 6M HNO3. So the most important things to solve this kind of problems is know that the moles before dilution is equal to the moles after dilution. So it means the molarity is equal to moles over volume. So the mole is same. So M1 V1 is equal to M2 V2. So for this question, 60M times V1 is equal to 6M times 50 milliliters. So we can do some algebra things to get the V1. So 6M times 50 milliliter over 16 millimole M is equal to 19 milliliter. Question B. Calculate the number of moles of AgCl precipitate collected. The mass of AgCl collected. This one we can find from the data table. So it is 29.2598 minus 28.7210, and it is equal to 0.5388 grams. Then we can calculate the mole. It is 0.5388 grams over the molar mass 107.87 plus 35.45 gram per mole, and it is equal to 3.759 times 10 to the negative 3 mole. Question C. Calculate the mass percent of silver in the alloy of copper and silver. The mass of copper silver alloy it is 0.7689 grams. We get it from the data table. And the last question, question B, we got the mole of Ag, which is 3.75 times 10 to the negative 3 mole. So we can get the mass of Ag, the mass of silver, times the molar mass of silver 107.87 grams over 1 mole. So it is equal to it is equal to 0.4055 grams. Then we use the mass of the silver over the mass of the copper silver alloy times 100% is equal to 72.49%. Conclusion: for the stoichiometry, the first step to solve the problem is make sure the equation is balanced. Because if it is not balanced, you can not use the ratio to solve the problem. And be careful when you convert like the mole, mass, and molarity. You need to know how to convert it. And because the stoichiometry, we need to do a lot of calculations, so remember to check the sig fig.